Welcome to Geometry Pre-AP. Today we're going to talk about inequalities of one triangle. So take a minute to pause the video and write down the essential question and the objective. Okay, now that you've got those things written down, let's get into this lesson. We have a few things that you need to take a look at. The comparison property of equality says that if A is equal to B plus C and C is greater than 0, then A has to be greater than B. Because think of it, like if you have 5 is equal to 2 plus 3. And I look at this quantity and this quantity. Which is bigger? The A is bigger because I had to add another number to it just to get equal to the A. Right? So the measure of an exterior angle of a triangle is greater than the measure of any one of each of its remote interior angles. So remember that we knew the exterior angle, angle 1, was equal to angle 2 plus angle 3. Well, this is just like the comparison property above. We know that angle 1 has to be bigger than either one of these two other angles. Okay, so if we look at this, it says use the figure right to determine why angle 2 is bigger than angle 3. Well, if we look at this isosceles triangle, we know that this angle and this angle are the same. And we know that angle 1 is an exterior angle for this triangle. So we know angle 1 is equal to angle 3 plus angle 4. We know that angle 2 is equal to angle 1. Therefore, we know angle 2 is equal to angle 3 plus angle 4. And then we now know that if 2 is equal to 3 plus 4, the angle 2 has to be greater than angle 3. So angle 2 is greater than angle 3. All right? So let's apply this right here. So try these two, see if you can show and explain why angle 1 is greater than angle 2. All right, so if you have any problems with these, make sure you ask when you get to class so we can go over these. Next, we have theorem 5-10 says if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So the longer angle is across the longer side. So in this case here, we have xz, this is larger than xy, which means this is the larger angle. Angle y is larger than angle z. So remember this, small angle across from small side, large angle across from large side. And of course, middle angle is across the middle side. This one is the reverse of that. This one says if angle A is bigger than angle B, then the side across from it must be bigger than the side across from that one. So that means side BC will be larger than side AC. So it's just the converse of the 5-10 theorem. So again, smaller angle, small side, large angle, large side. So large side, large angle, small side, small angle. So pause the video, read this question for a minute, and see if you can figure out the answer. And then start the video when you're ready to see what is going on. Okay, so it says town park is a triangle. Landscape architect wants to place a bench at the corner with the largest angle. Which two streets form the corner of the largest angle? So look, this is the largest street right there. So this is the largest street. So this is going to be the largest angle, which means these two streets form the largest angle. So MKLK Boulevard and Valley Road make the largest angle. Okay, if one side of a triangle is longer than the other side, then the angle opposite is. Okay, so just a reminder here. If we're going to look at this, we said listen from the sides here. So if I have the side of 3, that means angle D is my smallest angle, angle E is my next biggest angle, and angle R is my largest angle. So from small to big. All right, so if I go over here, here's the reverse of it. My smallest side will be MU. My next biggest side will be DU, and my biggest side will be DM. And we can do it for angles and sides, just like the theorem said. All right, so pause the video, do these two problems. Okay, now that you got these problems, if you have any problems with this, make sure you ask when you come to class. I'll be checking the work. So the triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So in order to check and see if something's a triangle, we have to check the sides. So if I've got a 2, a 3, and a 4, okay, I gotta check that 2 plus 3 is greater than 4. So that's 5 is greater than 4. I gotta check that 3 plus 4 is greater than 2. That's 7 is greater than 2. That checks. And then xz, which is 4 plus xy, which is 2, is gotta be greater than 3. And that 6 is greater than 3. If all these check, then we know it's a triangle. It is a triangle. All right? So let's apply this. Check and see if these three sides can make a triangle and if these three sides can make a triangle. Remember that when you're attempting these problems, to use inequality and do a check. So pause the video, do these two problems. Okay, so now let's check and see how you did. So yes, this one made a triangle. No, this one did not. And there's your reason. You can pause the video and look at the reasons if you need to. Okay, so which of the followings make a triangle? Check these. And I'll check your notes when you get into class. All right, so this is a yes. This was a yes. And this was a no. All right, so finding the possible side lengths. If you want to solve a problem and you explore the dimensions of a triangular sandbox and two sides are 5 and 8, what is the range of possible values for the third side? And we're going to use a triangle inequality to determine that. So let's look at some of the information. So first we need to know the side lengths are 5 and 8. We need to know the range for the possible values of the third side. And so our plan is to use the triangle inequality to write three inequalities and use the solutions of those inequalities to determine what's the greatest and what's the least. So if we look at our inequalities, we'll let x represent the unknown length. So we have this inequality, we have this inequality, and we have this inequality. You have to do it three different ways. Okay, and so when I'm done and I look at these inequalities, what's the lowest value possible? Well, there's a -3, but you can't have a negative side length, so that one is out of there. Can't use that one. So we got x got to be greater than 3, but x has to be less than 13. And so therefore my values are from 3 to 13, and we write that as an inequality of 3 to 13. So x has got to be greater than 3 but less than 13. Now it's not equal to 3 and it's not equal to 13. All right. Okay, so determine the values of these sides right here. And so I'll let you do these and I will check these when you come to class. All right, so I want you to check and see if this figure is a triangle. So pause the video, do these, and see how you do. When you do this, you should be checking for 4 different things. The angles add to equal 180. The sides, two sides have to add to be greater than the third. Small angle across small side. Big angle across from, oh, sorry guys, bad writing there. All right, big angle across from big side. So make sure you check all 4 of those things and see if this makes a triangle. All right, next. I will have a question just like this on a test, and there are a bunch of these on the homework, so make sure you do them. I will give you some common mistakes that are made. So it says find the value of x and list the sides in order from smallest to largest. So pause the video, make an attempt on this. All right? All right, so you can see here I started the process here. I lined up everything. So by lining up everything like this, I can easily go 20x minus 20 equals 180. I can combine my like terms are easy. And these are all the angles of a triangle. So let's look here. We've got angle J, A, and M. Okay, so I add 20 to each side. So 20x equals 200. X is equal to 10. So when I plug this back in, right here I got 60 minus 8, which is 52. Here I got 40 minus 5, which is 35. Here I get 100 minus 7, which is 93. So angle A was 93. Angle M is 35. And angle J is 52. Now what I see some people do, one of the big mistakes I see is people say, okay, it's angle M, it's angle J, and angle A. Well, that's great, but I said sides, not angles. So when you put your sides in order, you look for the smallest side, which would be JA. The next biggest side would be AM, and the largest side would be JM. And so this is the answer that we're looking for. So make sure you don't make the mistake of doing the angles. Make sure you do the sides. Details, guys. It's always about details. All right, so let's look at this problem. This is a difficult problem. I'm going to pause the video myself, and I'm going to do some work, and then I'm going to explain through it. All right, so let's look at the work for this problem. What I had to do was I had to say two sides added to be greater than the third side, and I had to do it three different ways. So I did this three different ways, 1, 2, and 3. All right. And so once you solve each one of these equations, you get three different values for x. So once you get all three values of x, you got to see what's going to work for all three equations. So if I look at this first one, x is greater than negative 11. So if I go to this number line, that was not. This is an open circle, and x is going to be greater than negative 11. Okay? Then x is going to be greater than 3. So x is going to be greater than 3. So x is going to be greater than 1/3. And so once I got all three of these graphed, you got to say, okay, well, where's my answer work for all three? Okay, well, it doesn't work at negative 11 bigger. It doesn't work here. So it's only right here in this area. So that means x has to be greater than, or greater than 3 to be an answer. So it means 3.1, 3.5, 4, 5, 6, 7. Only there will be the correct answer. So you work all three different, and with the one equations, when you're done with that, you graph on a little number line, you see which one is true for all three, and that's how you pick the right answer. It could be a range. You just never know. Remember that when you're working with an inequality, if you divide by a negative, you have to flip that inequality. All right. And that wraps up our lesson. Thanks.